Hello, everyone. My name is Ryan Shi, and thank you for tuning into this talk. So I'm a PhD student at Connecticut Mellon University working with Fei-Fan. So I'm very fortunate to be able to work on AI for social good as my thesis topic. And I'm very excited to share with you all what I've learned throughout this process. So just to be on the same page, AI for social good is a research theme that uses and advances AI to improve the well-being of society. Of course, this is a very broad definition, but I hope that at the end of this talk, your takeaway is that it's not just a simple collection of different research topics. Instead, it can be a discipline on its own. And in this talk, I'm gonna explore this very exciting and also very subtle interplay between my research and the real world. So let's start with the most intuitive connection from my technical research to the real world. I firmly believe that AI for social good research that only stayed in the lab, that kind of research doesn't fulfill its purpose. So I aim at doing research that can be directly useful in practice. And in the past couple of years, I've been very fortunate to work with lots of collaborators and nonprofits in several different domains. And in this talk, I'm going to focus on two of them, food waste insecurity and cybersecurity. So let's start with the first one. Food waste and food insecurity are two important problems that unfortunately coexist in many parts of the world. Food rescue organizations, they are a growing force of nonprofits that rise to answer this challenge. They basically serve as an intermediary between food donors and food recipients. So how this works is that when a donation comes to the platform, the dispatcher at the food rescue organization, they will match this donation with a recipient organization. And then they're going to post the information, this matching information, on their smartphone app. So here's the important thing is that the food rescue organizations, they don't transport the food themselves. They completely rely on external volunteers to transport the food. So they post the information on their smartphone app, and then their volunteers who have the smartphone app installed on their phone will receive push notifications and then see this rescue information. And then if these volunteers want to claim the rescue, they can just do it on their phone and then head out to pick up and deliver the food. So that's a clever idea, and it's also very necessary to rely on volunteers in order to scale up the operation. But at the same time, volunteers are not employees of the food rescue organization. So there's a lot of uncertainty about whether any volunteer would claim a rescue or not. And if things really fall through the cracks, sometimes it happens. Sometimes it's quite discouraging to both the donors and the recipient. So in our first project, in collaboration with a food rescue organization in Pittsburgh, we used a data-driven approach to find the optimal intervention and notification scheme. So specifically, this food rescue organization, they have a two-wave push notification scheme. So we found out how many volunteers we should notify in the first round, and at what time should the second wave of notifications go out. And also we found if a rescue has stayed on the platform for a while unclaimed, then when should the human dispatcher at the food rescue organization step in? When should they step in? So with all of this, we're trying to minimize the number of push notifications and also save the dispatcher's effort, while at the same time keeping the claim rate unchanged. So because like the notifications and the dispatcher's effort are really kind of the key scarce resource that we want to save here. And the technical work was published at IAAI last year, and our recommendation has already been adopted by the food rescue organization since then. So in our recent work, we dive deeper into the push notification scheme. We focus on finding the quote-unquote right volunteers. Why is that important? Because clearly, like, we don't want to send push notifications to all the volunteers for all the time, because people will easily get bored. They will mute the notifications. They will even drop off. So we want to find a small subset of volunteers who are likely to claim a given particular given rescue and then send notifications to them. This is a recommender system problem. And how do we do that? We basically develop a recommender system that can select a small subset of volunteers to notify for each rescue. And it actually improved the hit rate of push notifications from the previously 44%, which is kind of the status quo, to 78%, which kind of nearly doubled the number. And at the same time, there's another issue in here is the diversity issue, because we know that recommender system, they are inclined to send notifications to recommend items that are really popular, but recommend only a small subset of items, which is really bad in our case, because the volunteers who get notifications all the time might end up to be the most valuable volunteers to the platform, and we certainly don't want to annoy them. So we really have to diversify the recommendation. So to do that, we developed an online algorithm to dynamically enforce a diversity constraint as new rescues arrive onto the platform in any given day. Because the additional novelty here is that in traditional, most recommender system literature, like the data set is fixed. But in our case, the new rescue arrive into the system online, like we don't know it beforehand. So we have to cope with that. And so that's the technical content of this work, which is currently under review at a conference. And we are also planning to roll out a pilot study of this whole procedure later this year. Okay, so now let's switch gears to cybersecurity. My work in this space is centered around the game theoretic cyber deception. The philosophy is that, cyber attacks are inevitable, but cyber attackers, their time and effort are limited. So let's try to mislead them to attack less valuable targets, and they spend more time in the system, and then this gives us more time to find them and evict them from the system. So a way to formalize this problem is to suppose that each node in a network that we want to protect has some true features and some observed features. The true features, they are the true property of the network node. So they also determine the loss to the defender if this node is being compromised, and these true features are hidden from the attacker as well. And on the other hand, the observed features, they can be modified by the defender directly, and these observed features are obviously observable to the attacker, and they determine the value of a particular node in the attacker size. So now it's kind of intuitive. The idea is to manipulate the observed features so that a valuable target appears less desirable to the attacker, and of course vice versa. But the thing is, we don't really know how the attacker values different nodes and features, right? So we need to learn. We need to learn the attacker's behavior model, and then using the learned model, we can find the defender's optimal strategy. So in this work we published at GameSec last year, we provided a very rigorous end-to-end learning and planning pipeline with like theoretical optimality guarantee. So that's kind of that work. And in addition to that, we also developed a specific kind of attacks called, we also devised an approach to mitigate a specific kind of attack called watering hole attacks. So essentially what the watering hole attackers do is that they research their target users. They find out about their internet usage, they find out about their browsing habits, and then when their targets visit a compromised website, they will look at their network packets, because these network packets contain very useful information about their system property. And then based on the system property, they will send a tailor-made exploit to compromise the target's device. And so how does deception come into play? Deception comes here if we are able to modify the user's network packets in order to mislead the attacker to send incompatible exploits, and the attack will fail, right? So in this work at IAAI last year, we proposed an algorithm to compute the best defending strategy. But much more than that is that we also developed a browser extension to mitigate the risk of this kind of attack based on our algorithm. And at the bottom right of the slide, you can see a screenshot of the browser extension we made. So I just introduced 4 different projects on AI for social good. They solve different problems, and they are even in different domains. But as I work on them and as I work with other nonprofits, I started to realize a pain point. And this pain point is shared by a lot of AI for social good projects across application domains. At that point is when I realized, it's possible to bring my engagement with the real world back to my technical research. I proposed a new research problem, technical research problem. But before I go there, to convince you that I'm not overstating, I'm not making up of a pain point, I want to invite you to consider a few questions. And let's say, imagine you're working with a nonprofit, a government agency, or even like a non-tech company, anything like that. So first, let's say you've already got through all the hurdles and the legal stuff. So your collaborator now sends you their data. And did you ever find out that their data set, what they call a data set, it turned out to be an Excel spreadsheet of 1,000 lines. And then they somehow expect you to run a magical deep learning algorithm on top of it. Okay. And second, let's say the data size is no longer a problem, but then another problem is your collaborator hopes that you, as their AI machine learning expert, they hope that you can tell them what's the best intervention they can take next month. But the thing is, their entire data set was collected under a single default intervention that they have always been using for the past 5 years or even longer. So how are you going to do that? How are you going to find the optimal intervention? Are you going to make counterfactual assumptions? Well, that might work, but we all know that that's going to be a very slippery slope down there. So is there a better approach? And third, let's say, suppose that you've worked for several months and then you finally got your collaborator to test out your proposed intervention next month, and you think you're golden. But the night before deployment, you just become more and more upset. Why? Because you start to worry if you model the problem correctly, maybe there's some additional policy objectives that you fail to consider. And if so, your solution could turn out to be really disastrous in practice when tested out. And how are we going to face that? And that really ties into this last question I want to consider. So AI for social good researchers, we want our work to be impactful, but there will always be unintended consequences. We should, of course, try our best to scope out the problem beforehand, but we also need to acknowledge that sometimes there will just be stuff that we cannot realize beforehand. And then, do we throw our hands up in the air? No, we still want to account for these unintended consequences of our intervention in a principled way. So how are we going to do that? So if you've actually worked on the ground in any AI for social good domains, hopefully at least some of these questions already resonated with you. And as a first step to address these kind of challenges, we propose a new paradigm called bandit data-driven optimization. It has connections to several different lines of work, including data-driven optimization, like offline reinforcement learning, but it's technically most relevant to contextual bandit. Basically, this is a principal integration of offline machine learning prediction models that are commonplace these days, really, with online bandit algorithm. It's an iterative procedure. Okay, so at each time step, we receive a feature vector, and then we're going to use an offline machine learning model which is trained on all the previous data points we've seen so far to predict the label. And using this label, we're going to decide on what action to take this run. And we get a reward as well as a true label of the feature vector, and then we add that new data point to our pool of data points. But then I really want to dive a bit deeper into the reward here. The reward has 2 components. The first component is known to us a priori. This represents our understanding of the domain. AI for social good researchers, we spend a lot of time trying to make sense of the background domain and get all those knowledge. That represents that. The second component of the reward function is unknown. It's a bandit reward. And this is our acknowledgement that even though we try very hard to do that, there will inevitably be something that we just didn't know beforehand. Thus, we use we're gonna use tools from optimization to address the first component, and we're gonna use tools from Bandit or online learning to address the second component. But that said, how to combine the advantages of several things like online learning, offline learning, and optimization. Combine all of these, the advantages of all of this in a single unified framework in a consistent and principled way. How do we do that? That's not at all very obvious, and that's what we did in our recent work. So there, here we not only propose this new paradigm, we also propose an algorithm that solves this problem. It's called proof, or it's called predict and optimize with optimism in face of uncertainty. So it's a very dedicated and principled integration of the very well-known lean UCD algorithm with offline machine learning models. So we are able to show that, formally prove that it has sublinear regret. And well, you might have noticed that the vanilla Bandit algorithm already achieved routine regret. Our algorithm in practice can do much better than Bandit algorithm, but like applied in a vanilla way. So why is that? That's because we think that we explicitly account for the known objective in addition to the unknown objective, and this additional structure is justified, as I had explained earlier, in a lot of like AF social good domains. That's our prior knowledge. Okay, so I've been talking about this two-way interaction between my research world and the real world. But as I spend more and more time on AI for social good, I came to realize that both worlds are some sort of fantasy that some researchers, well, including me, including me, made up in their minds. And now I really hope to connect them back to where they belong. But in the interest of time, I'm just gonna mention my thesis or motivating questions without really expanding on them, and I'm happy to discuss that offline. So First, I've been talking about the real world. I've used the term real world many, many times in this talk so far already. But then what is the real world exactly? When we say my project worked, how does it work? Like, did my project only work on simulations? Did my project really work? And when we say my project really worked, what does it mean to say something that really worked? Okay, so that's the first thing. That's about how genuine we are with our work. And the second thing is about how genuine we are with ourselves. What's the goal here? Like, what's the end goal? How do we define success? And when can we claim success? So these are important questions to consider. But with all that, I'm going to wrap up. So, I'd like to first of all, thank Faye for everything. And I'd like to thank all my collaborators. And of course, I want to thank you for tuning into this video for this 20 minutes and taking up precious amount of your time. So this past year has been very rough on all of us, but I just cannot wait to continue with some of these works I mentioned here in the upcoming year, as well as pushing for new frontiers. So the papers that I mentioned throughout this presentation are listed here, and I'm very happy to chat with anyone offline, and I can be best reached by email. And my email address is ryanshi@cnpeyKy.edu. And with that, thank you everybody, and goodbye.